Guys, you wanted it and you will get it today. This is my complete programming tutorial for the MetaTrader 4. Usually I focus on the MetaTrader 5 on this platform, but there were so many requests for the MetaTrader 4, especially from the people in the United States who are stuck with the MetaTrader 4 for live trading. So this one goes out to all my bros in the United States. Have fun watching this programming tutorial. Also, it is really important. This is a complete programming tutorial, but you will have to watch it until the end to really learn something, to really pick some of the knowledge up. If you just skip through the video or if you just copy the code from the last few minutes of the video, you will absolutely learn zero. So if you want to do this, I mean, it's up to you. It's a free world. Everyone can do what he or she wants, but it's definitely not recommended. And if you just copy the code from the end of the video, you will be as stupid as you are now if you just do this. So trust me, watch the whole video in detail, do everything step by step, as slow as you need to watch it, and make sure to copy all the code that I write on your own PC to really learn something. But if you do this, I can guarantee that you will be a smarter person by the end of this video, and you will pick up the most important basic programming knowledge that you will need to write your own programs for the MetaTrader, especially the MetaTrader 4. So what will we do? In this video, we will have a look at a simple moving average crossover strategy. This is a universal strategy that is well known and publicly displayed by a lot of different traders, and it is a strategy that can definitely be used especially in trending markets. So on the screen here in my GBP/USD chart, you can see two moving averages already. The blue one is a slightly faster one with 20 periods. The red one is a slower one with 50 periods. And we will just watch for the crossover of these moving averages, and I put these vertical lines here where these crossovers happen. So this is the exact time when our automated trading strategy that we will create in this video will take trades. So we either open and or close trades on these crossovers, so we have a nice smooth operating system for the MetaTrader 4. Also, if you don't know what the moving average is, it is just the average of the last X bars. And you can, for example, take the close price of the last 20 bars and then this will be the moving average value for the current bar. You can find this moving average in the navigator of your MetaTrader 5 if you click on indicators, and then you can go to trend, indicators, trend, and here you will find the moving average, and you can just drag and drop it onto any chart, and then you can define the look of this moving average and click on OK, and it will be applied to the chart. I did this already, so I won't do it again, and we can jump right into the programming part. So when we want to write programs for the MetaTrader 4, the easiest thing to use, or the fastest way to do it is to use the MetaQuotes language editor. Just go to Tools in your MetaTrader 4, the upper left corner, and then go to MetaQuotes language editor. If you click this, it will automatically open the integrated development environment that we can use to write fully functioning programs for the MetaTrader 4. And here in this Meta editor, we can go to the upper left corner, click on New, and then select Expert Advisor Template. It's usually pre-selected. Click on Next, and here it wants us to choose a name. We will say, or I will say something like Moving Average YT YouTube. So this is my name for my Expert Advisor. You can choose whatever name you like. Then the rest can stay unchanged, and we click on Next, Next, and Finish. And this will automatically create a brand new Expert Advisor for us. So this is the skeleton of a new program, and we have some basic functions and we have some properties. So let's talk about this. But first of all, let's talk about these gray lines. All of these gray lines, they are just comments for the programmer. What does this mean? This means that these lines do not have any impact on the program. So for example, I can delete all of these lines here, then I can click on compile up here, which will turn this MQ4 text file into a executable, and it still works, even if I delete some of these gray lines. And actually, I want to go ahead and delete all of these gray lines because we don't really need them in such a small and simple program like this. Again, it's just a information for the programmer. So if you think you need comments to understand your code later on, like in 1 year or in several months, you might want to add comments. How to do this? It's really easy. If you want to have a single line comment, you can just go to a new line or any line pretty much and then write 2 of these slash signs, and then you can write whatever you want. This is a single line comment, and if I compile, it will still work because this line has no impact on the source code. But if I remove these slashes in the beginning, it will give us several errors down here in the toolbox because now this is part of the source code and it's not really useful part of the source code because it doesn't make sense for the program. So you will have to write a comment if you just want information for yourself or other programmers working on this project. You can also go ahead and say you want a multi-line comment. In this case, write 1 slash and 1 star. And then at the end of your comment, 1 star and 1 slash. This means everything in between is now a comment. And I could write whatever I want here. It's not part of the actual program. So let me delete this again, because as I said, we don't really need it here. So what do we have left? We have some properties left. And these properties will be displayed if we run the program. So if your code looks like this and you compiled it correctly, then you can switch back to your MetaTrader 4. Because now this program here, and do me a favor and go here to this tab where it says moving average or whatever name you chose. Right click it and then click open containing folder. And this will open the folder of your MetaTrader 4 where this program is located. So here you can now see 2 files with the name of your expert advisor. One is a MQ4 file, one is a EX4 file. Now I want you to delete the EX4 file. And now you only have the MQ4 file, which is this exact text file, so to say. But if I compile this and go back to the folder, you will see the EX4 file is there again. Okay, you might have to right click and refresh this folder, but if I do this, wait, let me refresh this folder up here. So if I refresh the folder, we can see now the EX4 file is there again, because the process of compiling means that you take this source code, this text, and you compile or you turn it into a program that is understandable or that can be understood by the computer, more specifically by the MetaTrader. So after compiling and after creating this EX4 file, you can now go back to your MetaTrader 4 and now you should find in your navigator the expert advisors folder, and if you open this, you can find the the moving average YouTube program here or whatever name you chose. You can now take it and drag and drop it on your chart. This will open the, first of all, the About tab for your program. And here you can see the name, the version ID, the copyright, and there's a link below it. And these are exactly the properties that we have here. So we can see there's a copyright, and we can change this maybe to my name or to your name. Just change it here in the green area where the text is displayed. And then we can also change the link, maybe en.bmtrading.de, which is my personal website. And then you can, of course, also change the version. So if I compile this and if we go back here to the program, we will see everything is updated. And I can actually also click on this link and it will open the link that we put here. So this is my website. Have a look at it if you're interested. So yeah, so much for the properties. But these 3 properties, they are just a information for the user of the program. Actually, they do not really affect the functionality of the program. So I could as well go ahead and delete all of these lines. And if I compile and run the program again, you will see this information is now gone. But it doesn't really change the functionality, so it's totally fine. You can use these properties if you like, but if you don't want to use them, you can also delete them. It will just save you some lines in the code of your program. Also, there's this one property which is strict. And this one, actually, it makes a difference if you use this one. And I highly recommend to use this strict property because it will tell your compiler that you want to write proper source code. Because if you don't use this, you can pretty much mess up your source code a little bit and it will still work somehow. It's hard for me to describe this, but yeah, just keep this strict property in all of your MetaTrader 4 programs because it might prevent errors at some point during running the program. And maybe it will increase the efficiency also. So if we compiled it like this, now all we have left are 3 functions. And functions always look like this. They have a signature, which consists of 3 parts. The first one is the so-called return value, or return data type of the function. Then we have the name, and then in these round brackets, we have the parameter list. You can see for this onInit function, for example, the return type is int, which means integer, which is a number like 1, 2, 3, 4, 5. And then the name is onInit. And then we have empty parentheses, so this function does not have any parameters. For the onInit function, this is a little bit different. The return type is void, which actually means that there is no return value. And then the name is onInit, and there's a parameter in the parameter list here. So let's have a look at these 2 functions first. But before we do this, I want to rearrange these curly brackets. So what I like to see is a curly bracket or the opening bracket directly after the signature here, and then the closing curly bracket in a new line after the return value. These curly brackets are wrapping the body of the function. What does this mean? It means that whenever this specific function is called by its name, then the body of the function will be processed by the PC. And where you put these curly brackets actually does not really matter. So I could also put it here, for example, and compile, and it still works. I could also put it here and compile, and it still works. But for me, this is the look that I'm used to, so this is what I use in my programs. But this is personal preference, and you can choose another place for your curly brackets. So if we compile it, and if we have a look at the onInit function again, as I said, whenever this onInit function is called by its name, it will execute the body of the function. So if we go inside of the body of the function and then just print or add print with a capital P and then just print, we can, in the round brackets following this print, we can add a text. And texts are always wrapped in quotation marks in programming, or in MetaTrader 4 programming at least. And I can print something like this is the onInit. And then I need another quotation mark here to end this text. And then I close these round brackets, which are the parameters for this print function, and then I end the line with a semicolon. This is a so-called print statement. What does this do? Whenever this print statement is executed, it will print this exact text in the experts journal of our MetaTrader 4. And again, this body here, so also the print statement, which is inside of the body of the onInit function, is executed whenever the onInit is called. So let's compile this again and let's run the program on a chart. And before we do this, we go to the terminal of our MetaTrader 4, and down here we want to go to the experts tab. So clear everything inside of this experts tab by right-clicking and clearing, and then go to the navigator again and find your program. For me, it's the moving average YouTube program. So let me drag and drop it on a chart, and then let me click OK. And you can see as soon as I do this, there's some information in this experts journal. First of all, we see the program is initialized. Then we see there's a print statement which says this is the onInit. And then it says loaded successfully. So when we activate the program in the chart, it's first of all initialized, which means the chart or the MetaTrader is calling the onInit function of a program automatically. And whenever the function is called, the body is executed. And inside of the body, there is this print statement. So this is why we see this print statement here in the expert journal now. And afterwards, the program is loaded successfully. This is because it will return init successful, which is pretty much just a equivalent of the value 1. So this means the initialization was successful. It's either 0 or 1, I'm not really correct, but it's a integer value. This init succeeded is just another, it's just a so-called enumeration value, but it will mean 0 or 1 in the background for the PC. And this is how the MetaTrader works, that knows that the initialization was successful. So then we can also go ahead and have a look at the onDinit function. And what happens if I write here, this is the onDinit. And if we compile the program again. So we will now see whenever, let me clear the journal, whenever I remove the program from the chart, like for example, I go right click, export advisor remove, it says this is the onDinit function, because in this case, the onDinit function is automatically called by the MetaTrader for all the programs that were removed. So you can see these functions are called by the MetaTrader, and this is because they are so-called event handling functions. So whenever there is a specific event, like the initialization or the deinitialization, these functions are automatically called. And these event handling functions are really important for us because our main source code or the main operations that we want to do will be placed inside of these event handling functions. Because if we would have no event handling functions at all, the MetaTrader would not really know when to execute which part of our program, right? Then we can also have a look at the onTick function. So let me print, this is the onTick. Let me compile this and let me run the program again. So first of all, the onInit function will be called, and then let's have a look at what happens next. Oh, the onTick function is called. And this function is called multiple times actually. And it is called whenever there is a tick in the chart. So whenever there's a price move, like up or down or whatever, this will call the onTick function. So this is in most programs the most important event handling function, because this is where we want to put our strategy logic, because we want to check with every single tick if there's a signal, if we have to modify the trading stop, etc., etc. So let me delete this print statement because it's really annoying to see this with every single tick. Whoops. And then compile, and yeah, let's have a look at the expert journal for one last time. What happens if we switch the time frame, for example? You can see this will also trigger the onDinit function in the old time frame, and then it will trigger the onInit function in the new time frame. Just do it on your own PC and yeah, see, have a look at what is printed here. So yeah, these are the event handling functions. So now let's go ahead and start with the actual programming logic, right? So what we want to do here is we want to have a look at indicators. So when we want to work with the moving average, we will of course need the value for this specific moving average. And in MetaTrader 4, the process of getting the value of one specific indicator is really straightforward and really simple. We can jump into the onTick function immediately. And what we want to do here is we want to create a new variable. And this variable will be of type double. So this double variable will have the name moving average 1, for example, or moving average fast, or whatever you want to choose. And then you write a semicolon like this. So you just add these two words and a semicolon, and if you compile, you can see there's no problem. There's just a warning that this variable is not used. So what did we just do here is we created a variable, which means that we told our PC literally that at some point we want to have a double value stored in the memory of our PC. What does this mean? You probably know the random access memory of your PC, or just like the memory in general. It can be the random access memory, the working memory, or the hard drive, which can also be used if the random access memory is full. So by telling our PC that we will need a double value at some point in the future, it means that in the random access memory, in the first place, it will block a specific amount of bits or bytes for this specific value. So in the random access memory, you can view it as a bunch of bits. Like for example, if you have 8 bits like this, which can be either 1 or 0, this would be 1 byte. And of course, you do not only have 1 bit in your random access memory, but for example, you have 4 or even 8. And actually, of course, you will have a lot more of these bytes in your random access memory. You usually not only have 4 or 8, but you might have something like 16 gigabytes. So you have a really huge amount of bits and bytes in your random access memory. And by declaring one variable of type double, for example, you are telling your PC you need 8 of these bytes blocked in the random access memory for a value that will be used by the moving average program in the future. So if we declare a variable like this, and if this code is processed, it will just block 8 bytes in the random access memory of our PC. Because at some point in the future, we might want to do something like this. We might want to store an actual value inside of this variable, and then the program will store it at this specific location in the random access memory. So you might have different questions. One of these questions could be, why do we store 8 bytes? This is because if you move your cursor inside of this double word, and if you click F1 on your keyboard, it should open the MQL4 reference. You can also go to Help and click on MQL4 reference. And this will give you the information about this specific data type. You can see the double data type needs 8 bytes of size. And this is because you will need 8 bytes to store the minimal or the maximum value that you can store in a double variable inside of the memory of your PC. So this is why you need 8 bytes, because these numbers that you can store in this specific data type can be as big as 8 bytes. There are different data types. For example, this double data type, it is a number that contains a decimal point and numbers after the decimal points. And we use this because we want to store the moving average values. And the moving average values, as you can see here, are usually prices. So they have, of course, a decimal point and numbers after the decimal points. But sometimes you don't need a double value. Sometimes you only need an integer value, which could be something like this. And you can, of course, do the declaration and the initialization in one process by writing a line like this. Like you specify the data type, the name of the variable, and then this one equal sign, and then the value directly. So this will create a integer value which is named int number, and it will directly store this value inside of the integer variable. So this integer variable, instead of a double variable, it only takes 4 bytes. So in the space that we need for 2 double variables, we could store 2 integer variables or values. So this is why different data types need a different amount of space in the random access memory, because the numbers are they just need more bits to be defined in the random access memory. And there are more data types. Like, let me explain the most important data types. So for example, we have double data types, which are numbers that can have a decimal point like this. Then we have the integer data type, which are numbers that do not have a decimal point. So only complete or real numbers like this. Then we have data types like bool, which is the most basic data type pretty much. It's just 1 byte, and it can be either true or false. So this can be either true or it can be false. So only these 2 values are allowed in a Boolean data type. And there are actually more data types, so let me explain the most important. There's, for example, string, which is a text value in MetaTrader programming. So text values are always wrapped by these quotation marks, and it could be something like this is a text value, but it can also be longer. So there's no real length limitation for string value data types, and this is why string data types the entry for this in the reference is a little bit more complex, because when you just declare a string variable, you cannot say at this point how much space you will need in the memory, because it depends on the length of the string, of course. So this data type is a little bit more complex and a little bit more flexible, but still the overall process is the same. You will just block a specific amount of bytes in the random access memory, and at this position you can then store a value. Also, what variables are is, for us, they are easy to work with because we have a name for the variable, and we can also address the value inside of this variable using the name. But for the PC, it's a little bit different. For the PC, this name is not like the name that is looking readable for us. But for the PC, this MA1 is not really a name, but more it is a pointer to an address in the random access memory. So the computer will know where to find this specific variable. So this is how to use variables in MetaTrader 4 programming. And let's have a look if I missed some important data types here. So you can see there are more data types, and you can read this if you want to understand more about data types. For example, let's have a look at one more, which is long. And long is similar to int. It will also hold values like this, but in a long data type variable, the values can be even bigger. And this is why the long data type needs 8 bytes of storage in the random access memory, while the integer data type only needs 4. So you can see there are some differences in these data types, but it all makes sense because the PC will know by seeing the address of this in the random access memory and the data type, it will know exactly how to interpret the value that it can be found at this location in the random access memory and how to work with it. So this is why data types are important. Okay, so let's get back to our program. And this was just for demonstrating how variables and data types are used in programming. But now we want to get the moving average value. And in the MetaTrader 4, it's really easy to get the value of a indicator. Actually, we just need to call one specific function. And in this case, it's the IMA function. I is a small letter I, and then MA is with capital letters. And if we have a look at this in the reference, again, move your cursor inside of this word, click F1, and it will say it calculates the moving average indicator and returns its value. For every function, which is a predefined function in the MQL4 framework, you can see the signature here in this yellow code box. And we can see the return value is indeed of type double. This is why we are able to store it inside of our double variable. And also we can see the name is IMA. This is why we call this name. And now we can see the parameter list. So these are the parameters that we will now provide for the IMA function, so the computer knows what specific indicator we want to get the data from. So let's have a look at these parameters. You can see all of these parameters are explained here, and you could read this. And this is what you should do if you're working with a new function. But for now, since this is a programming tutorial, I can explain all the parameters to you. So after writing IMA like this, you can write one of these round brackets. It's the opening bracket for the parameter list. And here you can see a preview of all of these parameters. And in fact, we just need these parameters, or the first few of these parameters, to explain to the program what specific moving average we need to get. So for example, if I just switch the time frame, the moving average values are completely different. If I switch the symbol, it's also different. Also, we can look, there are several inputs for this moving average indicator. So all of these things have to be defined. And this is what we do here in the parameters of this IMA function. So if we go to our source code, we can see the first one is actually the symbol. So we could write something like euro US dollar. And this would be euro US dollar. But since we are running it on GBP US dollar, we would have to provide GBP US dollar. So you can see it's a little bit stressful to change this for every symbol. So there's a quick solution for this. You can just write underscore symbol like this. And if you have a look at the reference, this underscore symbol is a variable that is also predefined. and it will always contain the symbol name of the current chart. So if I'm running this in GBP US dollar, it will be GBP US dollar. If I'm running this in USD Japanese yen, it will be USD Japanese yen, right? Second parameter is the time frame. And I could say something like, you can see it's an integer value. So I could say something like 60. But it doesn't really make sense because I can also say period and then, for example, period current. So if we have a look at this in the reference, you can see this period current will hold the value 0. This period H1 will hold the value 60. So it's pretty much equivalent. It's just part of a enumeration. And enumerations are used in programming because these IDs are easier for a human programmer to understand and to read. But under the hood, for the PC, if I write period H1 like this, for the PC, it will be the value 60. And this is why this period whatever can be used as an integer value. Because for us, it is a readable enumeration type, like period current, period M1, period H1. But for the PC, it will automatically turned into the integer value if we compile the program. Then the next few parameters are the actual parameters for the moving average. So again, if we have a look at the inputs here for the moving average, we can see there is the period, for example, the shift, the moving average method, and the applied to price. We can find all of this here and now. So we can say, for example, the period should be 20. Then we can say the shift should be 0. The MA method is mode EMA, and you can also read about these enumeration types in the explanation of the IMA function. So just press F1 again, read the IMA function, and you find in the explanation for the parameters, for example, these links here to all the enumerations. So if I click on this enum MA method, you can see all the allowed identifiers here. All of these IDs can be used. So I can use EMA like I did. I could use mode SMA for a simple moving average or a weighted moving average, all of these things. Same process applies to the applied price. So here you could also read in the documentation, but I will just go with a close price. And the last parameter is not for the moving average itself, it's the shift value. And I will go with 1. So if I end the parameter list closing these round brackets like this and the semicolon, I can compile it and I should not see any errors. If you see errors right now, make sure that you placed all your commas correct, that you put the semicolon, that you have the opening and closing bracket correct, and that you write everything like I did it here. So let me print the value that is now in this MA1 variable, like this. If I compile it like this, it will now print the value in the onTick function. So you can see it here. So let's have a look at the data window. Go on View, Data Window. And now let's use our cursor here in the chart to have a look at the last bar. And let me move to the last bar. And you can see in the data window, the value for this last bar is actually displayed down here in the experts journal. And this is because we used the exact parameters for this blue moving average. So it's a 20 period exponential based on the close prices of the candles. And this is exactly what I put here. 20 period, no shift, exponential, price close. Also, I put the value 1 for the shift, which means I will be getting the value for the last bar. So the shift defines what specific value you want to get. And the moving average or any indicator has a value for every specific bar, and it's always changing. For example, if we go ahead and also print or get the value for the moving average at bar 2, at index 2, the rest is completely the same. I just copied this line. I can also print the value at MA2, so at the second bar, and if I compile this, you can see now we will also print this value here, which is stored in our MA2 variable, right? So this is how you can use the shift value. So the shift value starts at the current bar also always, which is index 0. Then the next bar is 1, the next bar is 2, the next bar is 3, 4, 5, 6, 7, 8, 9, 10, and so on and so on. So by using this shift value, you can address every single moving average value in the chart. And actually, we want to use these two values for the first moving average. We also want to use them for the second moving average. But before we do this, and actually this is MA1 or MA fast at index 1. So we could do something like this as the name for this variable. And we can say MA fast at index 2. And what I would also recommend is not hard coding these parameters here, because you might have a user that doesn't want to use the 20 period moving average as a fast one, but maybe the 10 period moving average as a fast one. And it should be a simple one. So if I click on OK, you can see now that it changes the look of this moving average in the chart, but the calculated values by the program are still based on the 20 period exponential moving average. So the user of the program would have to change this in the source code. He would have to go here and say 10 and mode SMA, but this is not really easy, right? So what is a better way to do this is by creating input variables. So go at the very top of your program, outside of any of these event handling functions, and create some variables here. For example, int MA periods, or MA fast periods. Here you could say 20 like this. And if you compile this, it works, everything's good. And now we want to use this specific variable. Also note that I always like to use my input variables with a capital letter at the beginning and my normal variables with a small letter in the beginning. From this point on, it's always camel case, which means that every new word, so to say, in the name of a variable starts with a capital letter, which will increase the readability. Now I could go ahead and instead of writing 10 or 20 or 30, I can just use the MA fast periods every single time. And I can do this for all of these parameters. So I can say, for example, enum MA method, and I say MA fast method, and then I say mode SMA, for example. I can say, instead of hard coding mode SMA, I say I want to use the MA fast method from the MA fast method variable. Also, I do the same for the MA fast price. And also here, MA fast price. If I compile it like this, there will be an error because we have to define this MA fast price. So let's go here, MA applied price, MA fast price is price close. And if you are wondering why I'm using this enum MA method and enum applied price as a data type for these variables, it is because these are, again, you can read it in the documentations, these are enumerations. And we can use enumerations in the source code because it's easy for us to read it, and we can use the IDs, but for the PC, it will then automatically be turned into these values that are written here, which are no more than integer values. But yeah, we can use these enumerations, which makes working with these variables easy and handy for us because we know exactly what values are allowed in these variables. So if I compile this, you can now see whenever I change the value up here, for example, it will change the value for all the places in the code where this specific variable is used. But still, the user of the program is not really able to change this without changing the source code, right? And you can change this easily by writing this one word, a variable modifier in front of these variables. Just write input in front of them, and if you compile it again and go to your MetaTrader and open the moving average YouTube settings by double-clicking the smiley, you can see now we have the inputs tab. And here we can see all of these variables now. And you can see we can easily change these values here. And this will then automatically change the values of the variables in the program, which means that the user is now able to change the look and the calculation of these moving averages. So what we want to do now is we want to copy these lines, copy, paste it here, paste, and now we, instead of MA fast, we want to write MA slow for these 3 variables. And then of course we want to exchange this here and maybe use 50 for the slow moving average. And now also down here we want to copy these 2 lines, so we want to create the MA slow 1 value or variable. We'll call the IMA function again. We'll use this chart symbol again. Oh, and there's one thing that we can also use as an input variable, which is the time frame. Maybe we will do this at the very top using enum time frames, and then we can say something like time frame period current, and now we can also use this as the time frame value or the period value here. No, it's the time frame value for the IMA function. And I will use the same time frame for all of these MA calculations. And then here for the slow moving average, we now just use the MA slow periods from the inputs here. And then we use the shift value of 0. I will just hard code this because I usually don't change it. But you could also create an input variable for the shift value. Then we go with the MA slow method and the MA slow applied price, like this. And then we go shift value 1 again and shift value 2 for the second moving average slow variable. If we do it like this and compile, you can see everything is working just fine. And you can again print these values. You could also write a comment, which is then a chart comment. So here you could say MA fast at 1, and you could say, and I would recommend to use the double to string function, which is essentially just a function that converts a numeric value into a text string. So you can see it requests a double value as a parameter, and it will return a string value. So double to string, here we just provide a double value, which is our MA fast value, for example, and then we have a specific amount of digits, which is the digits after the decimal point that this value should be rounded to. And here you can use underscore digits, which works similar to the underscore symbol function or variable, but this one holds the amount of digits after the decimal point for the chart symbol. So for example, for GBP US dollar, it would be 5. For USD Japanese yen, it would be 3. So if we do it like this, we can always use a comma to concatenate multiple text values in this comment function. So I could also go ahead and use \n to go to a new line in this chart comment. You will see this in a second. And then we can also print the MA fast at the second bar in the chart. And then we can do the same process over and over again to print all the values in the chart comment that we want to see. So for example, also the MA slow value, and last but not least, the MA slow value at the second last bar in the chart, like this. So if you did this, and if you did not mess up your brackets or your commas or your semicolons, then you should be able to compile it. And then if you go to the chart again, you can see with the next tick, all of these values will be printed in the upper left corner of the chart, and we can see the values for the MA fast at the last bar here, and also the previous bar. And oh wait, I have to change this to 20 again and use the simple moving average here for everything. So these are the same moving averages than the one that the program calculates. But now you should see the MA fast value should be this one. The MA slow value should be this one. You can always compare the values, the upper left corner of your chart, with the values in the data window here. And yeah, you can also see this for the previous bar. So now you can see we actually got the values for these last 2 bars. And these are the values that we will now use to figure out if there was a crossover of these moving averages. So how do we do this? How do we figure out if these moving averages crossed? So actually what we want to do is we want to check if the value of the fast moving average is, for example, below the value of the slow moving average, and if the value of the previous fast moving average is above the value of the previous candle for the slow moving average. And we can do this by using a so-called control structure in our source code. Because right now, whenever the onTick function is called, everything here is executed, right? But this is not what we want to do, because, for example, we want to open positions only if there is a signal. So we will use a so-called if statement for this, which is a simple control structure. And you can just write if, and then in round brackets, you need a condition. And then you close the round brackets, and then you have a body of this if statement. So this is the basic look of a if statement. So first of all, let's take care of our condition. A condition can be either true or it can be false. If it is true, we will enter and process everything that is inside of the body of this if statement. So let's work out our condition. Here we want to check if the MA fast 1 value is greater than MA slow 1 value. So I want to check if the value for the moving average, for the fast moving average at the last bar is above the value of the fast moving average of the last bar, the slow moving average, sorry. Also, we want to use another condition, and we can combine multiple conditions using these conditional operators where we have AND, this is a AND, this is a OR, and yeah, I think we basically have these two, right? So we can say we want to combine multiple conditions. So the overall condition is only true if these two conditions are true. So this has to be true and this has to be true. Only if both of these conditions are true, we will enter the body. There would be a difference if we would use this OR, because in this case, only one would have to be true in order to enter the body. But here we want to check both conditions. So if both of these conditions are true, we can print something like by signal. Something like this. So let's compile this, and let's now go back to our MetaTrader 4 and see what's in the expert journal. And there's nothing. So is it not working? No, it's because there is no signal. So let's have a look at this in the MetaTrader 4 tester. Go to View, open the strategy tester quickly. And here in the strategy tester, and let me quickly close the terminal. In the strategy tester, you can now select your expert advisor you want to test. I will go with my program, of course. And then you choose the symbol that you want to test. Doesn't really matter, but we can go with GBP US dollar here because this is the one that I see on the chart. Wait. GBP US dollar. There it is. And then I would suggest you use every tick based on real tick or every tick calculation method. And then you choose a period here, and you can use a date that you want to test. Yeah, I would just go with maybe the last 2 months. And then it's important that you tick this visual mode here. And yeah, that's pretty much it. And then you can also, or you could use or change the expert properties here and change the inputs here for the test, but I will use the default values, and I will just click on Start in the lower right corner. And this will create a new window, and it will simulate this specific program in the selected time frame for the selected symbol. So this is a good way to check if your program or the source code that you wrote, if it's actually doing what you want it to do. So I will have to wait some time until my data is loaded and my test, and then we can see this. Okay, so here we can see it on the chart now, and you can see it is giving me the values of the moving averages in the lower, in the upper left corner of the chart. And I can also slow down or speed up the testing process here. But what I want to do is, first of all, let me use the moving average indicator here in this tester. So I will go to moving average and run it in the tester with the 50 period, and I will run it in it again with the 20 period. So I have both of these indicators in the tester visible, so I can see when there's an actual signal. So as soon as this blue moving average jumps above the red moving average, we should see the print statement, right? So let's wait for this to happen. There was a signal, and let's go to the journal, and we can see buy signal was actually printed at a time of 2:45 until 3 o'clock, because this is when in the last 2 bars there was a crossover happening. So this is working perfectly so far. Also, what we can do is, wait, let me delete this from the chart here. Remove, and let me also delete the chart objects. So let me delete all of these lines. And then what you can do is you can go, for example, right click this chart, go to template and save template. And I want to save this template as tester.tpl. And just replace the existing template, because if I do another test now, it will automatically load these chart settings. So it will automatically load a chart with the moving averages applied. And this makes it easier for me to test because I don't have to apply the moving averages every single time, right? And yeah, you can see this is still giving me the signals and everything, so everything's good. So let's go back to our source code. Oh, wait. Didn't want to close the MetaTrader 4 here. But yeah, I want to go back to my source code. And what we want to do is, or what we saw is that with every tick inside of the bar where this crossover happened, we will print this. And this is not exactly what we want, right? Because we only want to print this once per bar. So we will have to make sure that all of this code is only processed once per bar. And to achieve this, we want to create a new variable up here on a global scale, and we name it bars total. And then in the onInit function, we will initialize this variable. We will say bars total will be initialized with a return value of I bars, where we get the total amount of bars for the current symbol and for our time frame that we use. You can also read this in the documentation. You can see this will just return the total number of bars in the chart. And we will create another variable in the onTick function now, which we call bars. So this is a different variable. These variables are completely different. And this variable will also get the value of I bars. So now this variable also holds the value of the current amount of bars in the chart. Now we want to check with a if statement if bars total has a different value than bars. And this is a comparison operator, which means that these values are different. And then we can go inside of the body if these values are different. And here we want to put everything that we wrote until now. So just put it like this. So make sure that this opening curly bracket here is closed down here. And then take everything in between and put the tabulator button on your keyboard like this. It will move everything to the right. So you will know that this is part of the body of this if statement. So this is why you should always structure your code. So when something is in a smaller scope, like this, it will be moved a little bit more to the right. So this is how you can structure your code to increase readability. So what does this mean, that this is in a smaller scope? This means that this code is only executed if this if statement is true. Also, you can see that all of this code is also moved a little bit to the right compared to the onTick function signature. This is because this code is only in the scope of this onTick function. So it's only executed if the onTick function or the body of the onTick function is reached. While the onTick function itself is on the most basic global scope because it's at the very beginning of a line, which means that this onTick function will be called at the highest level, so to say, by the MetaTrader. And also realize that this bars variable is in the scope of this onTick function. So it only lives inside of the body of this onTick function. We could not change the bars value here. I cannot do this. I will throw an error because this variable is only living in the body of this onTick function. This is why it's in the body of the onTick function and it's moved a little bit to the right. But if I try to change the total bars value here, or bars total, like this, it will not throw an error because the bars total variable is defined at a global scope. So you can see this one is at the very left side and it's not inside of the body of anything. So we can use this variable everywhere we want, as we do here and here, but the bars variable is only living inside of the body of this onTick function. So this is the difference between global variables on a global scale or scope, and this is a local variable which is only available in the onTick function. So, and this is also why this bars variable will get the updated value for the total amount of bars every single tick, but this total bars total variable does not. It's only initialized here in the onInit, but it's not updated on every tick. So this value stays the same, even if this changed already, because there's a new bar. And then this is a good mechanism to realize if there's a new bar in the chart, because now we will just update the value in the bars total variable when there's a new bar, and then we process this only once for a new bar, and then that's it. So if we compile it again and run the same test again in the tester, you can see that now we still get the buy signal here in the journal, but we will only get it once. So let's wait for the crossover. There is a buy signal, and it will print buy signal, but only once if there is a buy signal. So let's go for the next buy signal, and let me speed this up. There's a sell, but there's another buy signal. So we should see a buy signal at 0 o'clock or midnight at the 28th of November here. And indeed, we do see this. Oh, actually, we see it at this bar here already. Yeah, because there was a crossover before. But yeah, you can see we only get this signal once for a bar if there is a crossover. So let's go ahead now and also check for sell signals. And this is really easy actually, because we just have to write if MA fast 1 is smaller than MA slow 1 and MA fast 2 is greater than MA slow 2. So we literally just turn these smaller than and greater than signs around. And then we can write sell signal, and let's add some exclamation marks to make this look important. And then we click compile, and if we go to our program, we can now run this, and we'll now indicate all the sell signals also in the journal. So let's have a look at this. So we can see there were several sell signals already, and you can see buy signals and sell signals are now taking turns here. So we always see a buy signal and then a sell signal. So this is how we can build our condition. So next step would be to actually open these positions, right? But first of all, let me show you that instead of writing if and if again, we could also say if and then else if, like this. So this is now a if and else if structure, and you can use this whenever you have two or multiple if statements that cannot be true at the same time. So if this is true, this can never be true, because it's just not possible. So then you can combine multiple else if statements, and I could do more like these. I could combine as much as else if statements as I want, and the benefit is that if this is true, it is not checking this condition at all. So it might speed up your program slightly, but actually in modern times, like with the computing power, the fast PCs that we have, it actually would not really make a difference if you write it like this or with the else if. But it's still good for you as a programmer to understand that this is like a if else if structure and only one can be true. Alrighty, so let's have a look at opening our positions for this program. And actually in MetaTrader 4, it's super simple and a lot easier than in MetaTrader 5. You can just go to the position in your Expert Advisor, your program where you want to open a position, and then you just say order send, and that's it. There's one function that you can use right away, and you just have to provide some parameters. So as usual, the symbol, which will be our chart symbol, then the command. And again, you can read about all of these kind of parameters in the documentation. You can choose one of these trading operations. Since we want to open a position right away, we'll go with OP, I think it's order properties or operation. We go with OP buy and OP sell. So let's go with OP buy if we have a buy position. Then the volume. Here I usually like to make this a input variable. So I will write lots with a capital letter L. And then I will go to the top of my program and say input double lots, and I just choose a default value, which can be changed by the user later. So we provide these lots. Then we have the price, and here we have to go with the current market price. I think, wait, is it written here? Order price. Yeah, we can just choose the current ask price to open a buy position. So how to get the ask price? Actually, in MetaTrader 4 programming, we could just write ask like this because there's this predefined variable. This one is not available in MQL4 programming, which is actually one of the differences. But here we could just use ask. It's the last known seller price. You could also go with symbol info double underscore symbol ask. So this is what you would do in MetaTrader 5. It also works in MetaTrader 4, but you can just choose ask also. Then I always recommend to round these values so you don't have problems with any unwanted numbers after the decimal point. So you can just use the normalize double function for this. It's a really simple function. It will just round a double or float value to a specified accuracy. And the accuracy is defined by the amount of digits. And we used this before in the double to string. It's just the amount of digits after the decimal point for the current chart symbol. So now we have the entry price. We can use this here for the parameters or for order send function. Then next one is slippage. For buy positions, I usually just go with a really big number because I want this position to be opened at all costs, so pretty much. And then we can use a stop loss. I will choose 0 here. I will choose take profit 0 also. And then we can use a comment here. Yeah, it's always a good idea. Maybe let's make this a input. We can say order comment, something like, oh wait, we cannot use this. This is predefined. Let's use commentary as the name. So we can say MA crossover, like so we know what EA opened this position. So let's go with, wait, where's my function here? Order send, and then I will just choose this commentary variable as a comment. And then we have the magic number. And yeah, you can see this is an optional parameter, but in this case we will use it. So let's create another variable here, input int magic, and we can just choose any number. So this magic number is just a number that you can store for every single order in the MetaTrader 4. And all of the orders that are opened by expert advisors can have this magic number. For trades that you open manually, the magic number will always be 0. But if there is a magic number, it means that an expert advisor opened this position, and we can use this magic number later on if we loop through all the open trades to find the trades of our specific expert advisor. So let's just use the magic number from the inputs, so the user is able to define the number there. So let's use magic here, and now we have the expiration. This is a parameter that we do not need because we open a buy position. This would only be useful for sell stop or limit orders, like stop or limit orders. So we use 0, which is also the predefined value here. So you can see whenever you see in the parameter list that there's the name of the variable and then a equal something, it means that there's a default value for this parameter. So we do not even have to provide this. We could end like this. And yeah, it would be totally fine. But we can also say 0, and then you could provide a arrow color like color blue for buy positions, which means that it will draw a little arrow there for the position opening. And yeah, so let's have a look at the order sent again. You can see the return value is of type integer, and this return value is the you can read it here. It's the ticket number of the position that would be opened here. So you could say or you could say int order is equal to order sent, something like this. This will get rid of the warning here. But the warning is not really an issue. You could just keep the warning because it's not a problem at all. So let's now do the same thing for sell positions. Let's say int order sent, and in this case we still use symbol, but here we use OP sell because we want to sell. We will also use the lots. We will calculate the entry, but this time it's the bid price that we use, and we can also use bid, this system variable, which holds the last known bid price for the symbol, and then we want to round this, of course, like this. And whoops, so, and then we use this bid price here, or the entry variable, which holds the rounded bid price. Then we have a big number for the slippage, so we can make sure that our position is opened every time. And then we choose 0 and 0 for stop loss and take profit. Comment will be commentary again. Magic will be magic again. Expiration is 0 because there's no, it's not a pending order. It's a market execution order. And the color can be red, for example, for sell orders. And that's it. If we compile this, it's really this simple. This one line will open a buy. This one line will open a sell position. And you can always use order send function for market orders, for stop orders, and for limit orders. You just have to adjust these parameters, but the function will understand what position you want to open because you define it here as the command. So let's go back to our testing environment and let's run the same test. I will just give it a go without changing the inputs. And once the test is loaded, we can see that now if there is a crossover, and there was a crossover here, we open a buy position. Of course, we cannot open the buy position down here where the moving averages are, but we are only able to use the current market price. I mean, this is pretty self-explanatory. So yeah, let's see what happens if we have a sell crossover, and there it is, and there's our sell position. So you can see positions are open with 0.1 lots because this is what we chose. We can also see that these positions are never really closed, and this is what we want to do now. Because we just realized that it's really simple to add a TP and a stop loss. We just have to calculate it, and then we can update these stop loss and take profit parameters for the order send function. So let's just create another variable here, and we can say the stop loss should be entry minus, and we can, for example, a new or easy mechanism is to just use a percentage of the current price. So for example, we could say we create two more inputs here, input double TP or SL percent 0.5 for example, and let's go with TP percent, could be a little bit more, but I mean the user is able to change this, so we can just choose a default value and it's not that important. So compile and then go back here where we just created this stop loss variable. So we go entry, and then for buy positions, we say minus entry. Oh, we don't really need this bracket. We can say entry multiplied with SL percent divided by 100. So like this. And then do not forget to make to round this. It's really important to round this because otherwise you will get errors because of this calculation. There can be digits after the decimal point that are like 5, 6, 7, 8, 9, 10 digits after the decimal points because of the calculation. So you really need to round it to the precision for your chart symbol. And we can apply the same process here when we calculate our TP. Let's say entry is entry plus multiplied TP percent divided by 100. And this will give us the TP, which is 0.5, or in this case, 1% above the current position opening price. And then, of course, do not forget to round this to prevent any errors. And let's say SL and TP instead of 0 and 0 for stop loss and take profit parameter. And then we can just apply the same mechanism here for the sell position. Here, of course, we would have to say entry plus entry multiplied with SL percent for the stop loss. Then rounding, like always, SL digits like this. Then we go TP, entry plus, entry minus, entry multiplied with TP%, because the TP for sell positions is of course below the entry price. And do not forget to round all of this again. That's it. Don't forget to exchange it here, like 0 for stop loss has to be SL now, and 0 for TP has to be take profit now. The rest of the parameters are unchanged. And this will do the trick. Let's go to our testing environment one more time. Let's run the exact same backtest, but now we can actually use or we will see a TP and a stop loss. So here you can see TP and stop loss are placed, and this should be a distance which is 0.5% of the current market price, and this should be around 1% of the current market price. It's rounded, of course. So now if one of these levels is hit, the positions will be closed. And yeah, also our sell position also has a TP, and literally like all of these positions will have TP and SL now. And I just realized maybe the distance is a little bit too much. So maybe, you can, since the user is able to change this, we can go, for example, to the 1 hour chart. And here the distance will make more sense, I think. And since we use the time frame current in the settings, we will now run the expert advisor in the 1 hour chart. And if we do this, I think the TP and SL distance makes more sense on the 1 hour chart, where we have a little more distance here. So you can see, here it's more likely that the TP and SL will be hit before we see like a lot of different positions at the same time. So and if you go to smaller time frames, you would probably choose a little bit smaller input for TP and SL. But like this, you already have a working program. It's really this simple. So if we have a look at the code again, in MetaTrader 4 programming, you can really write a fully working program with just 70 or 80 lines of code. And you could even get rid of some of these lines, like the comment is just the information. Okay, so next up on the list are functions. So now I'll show you how to write your own custom functions. So first of all, let's talk about when to use your own functions. So whenever you have something in your program that is done multiple times, then you want to use a function for this, because then you will be able to just call this function, which is usually a one-line statement, instead of writing the whole code over and over again. Also, you can use functions if you have a block like this, like one specific task, which has only one purpose, like opening a position. So this block here only has the purpose to open a position, but it's still taking like 10 lines in our onTick function, and it makes the function so big and a little bit harder to read. So instead of doing all of this, like writing all of these lines to open a position, it would be easier to just call our own function, which we can call execute by, for example, like this. So we can call a function like this. We use the name, and we always need to add the parameters, the list of values for the parameters. But in this case, we will use empty parentheses, because the function that we will create now does not need any parameters. So if we compile this, you can see there's a problem, because this function is not defined. But this is what we will change now quickly. So just go to the very end of your program, outside of any other function on the global scale, and write void execute by, and then these around opening and closing brackets, which is the parameter list. Then I need to add these curly brackets for the body of the function. If we compile now, you can see the error is gone, because now when the program sees at this point that the execute by function should be called, it will search in the same program for this function, and it will find it here. And then it will execute everything that is inside of the body of this function, and it will eventually return a value of this specific return type. But as we talked about before, void is pretty much a empty data type. So this function will not return anything. We could also say the return value is int. So we could return the order ID, for example. So if we compile now, there's a problem because it says in this function we are saying that it will return an integer value, but it doesn't. So if you define a return value other than void, like void is totally fine because the program does not expect a return value, but if you choose any other data type as a return value, the function expects you to return something. And it can be done by writing the return keyword and then return a value like 1. So if I compile now, the error is gone because I say I will return a int value and I do this indeed. So if I compile, the program is happy again. So what do we want to do in this execute by function? We just want to take all of this pretty much, right click, we want to cut it from here and paste it in the body of the execute by function. And if you listen carefully, you will understand why we do this. But first of all, let me select everything again and let me press Shift on my keyboard and the tabulator button to get this to the left a little bit, because now it's on this in this scope here, but it only needs to be moved one time to the right because it's directly inside of the body of this execute by function. So now we do all of this kind of stuff in the execute by function, and the program will still do exactly the same, because when we reach this point in the source code, it will see execute by function is called, then it will search for this function, it will find it here, and it will execute everything inside of the body. So the complete same code is executed, but this time it's moved outside of the onTick function, and the onTick function is just more handy and easier to understand, because if we see this, we know exactly what this will do, because the function name pretty much tells us what it will do, and we can be pretty sure that this function will open a buy position for us. So let's make one more adjustment. Here, of course, we don't want to return 1, but instead we want to return the order ID. Also, we could save us this step and we could directly say return the return value of this order send function. So if we compile, everything's fine and we're good. We could also have parameters here for our own function. So we could say, for example, we want to have, I don't know, just anything, like just a number. We don't really need this, but just to demonstrate how this works. Like if we have this parameter here, like if we add a parameter to this list, and we could have multiple here, number 2, for example, like we could have a whole list of parameter variables. If we define them here, and if they do not have a default value, we will have to add values if we call the function. So here we would have to provide 2 values, an integer and a double value, and now the error is gone and the program is happy. So if you have parameters for your own custom functions, you can then use them. Like for example, I could say print number and number 2, because these parameters that are passed up here when we call the function, they will then be stored inside of these variables, and they can be used by using these variable names inside of the function. But again, for the execute by function, we don't even need this. This was just me explaining you how parameters work for your custom functions. But let me just delete all of this again. And now we have the execute function fully working, fully functioning. Also, we will do the same thing, of course, for execute cell, because it just makes sense to move this block outside of the onTick function and make the onTick function a little bit shorter. So let me cut this here. Instead, we will just call the execute cell function like this. Don't forget the empty parentheses and the semicolon. And then we will paste it here in the execute cell function. And again, we will move it a little bit to the left because it's directly inside of the body of this cell function. Also here, instead of saving the order ticket in a order variable of type int, we will just return it as a return value of type integer for this execute cell function. So if we compile this, I mean, we didn't change the functionality of the program, but we are using our custom functions now. And if we test this in the strategy tester, you will see it still works just fine. So if there are positions opened, it will send the order, open the position, TP and SL, everything's in place, everything's working just fine. And this is how you can use your own custom functions. And there's another benefit like of using these custom functions. I could say if I want to open 2 positions, I can just call it again. Or if I want to open 3, I can just call it again. In this way, you can, for example, open multiple positions, and you could also say you use a different TP and stop loss for all of these positions. Maybe you could use parameters for this. So if you want to make some adjustments to your program, this is a good task that you can do to learn a little bit about programming by trying to add or to open 3 positions, for example, and all of them having a different TP and stop loss distance. That's a good task. But in this video, we won't do this. In this video, instead, we will have a look at loops now, because we want to add a trailing stop, and we also want to get the opportunity to close positions if there's a counter signal. So outside of our onTick function, we could add the trailing stop, but we could also add it here inside of this if statement. So it depends what you want to do. Like if you want the trailing stop to be processed on every single tick, you will have to add it here on in the body of the onTick function directly. But if you want to have it processed only once for every new bar, you have to do it here. So this is what I want to do now. So here I want to say for int I is equal to orders total minus 1, and then I say I is greater equal 0 and I minus minus. Okay, this is super confusing, right? I totally get you, because we never worked with for loops before. But let me explain. It's really simple. For loops are just another form of control structure. They are a control structure because they will structure the flow of your code pretty much. So when the program gets to this point where the for loop is indicated by this for keyword, then the program will have a look at these 3 sections, because in the round brackets following the for keyword we have 3 different parts. The first part is the precondition or the initialization of the for loop, and this part here is only executed once when the program reaches the for loop. So it will create an integer variable which is named I, and this integer variable will get the default value assigned, which is order totals minus 1. So order totals is just one of these functions which is part of the MQL4 framework, and it will return the total number of market and pending orders. So it will pretty much just give you the total amount of orders. So if you have 3 orders open in your account, it will be 3. As easy as this. Also, since we are here in the MQL4 reference, you can see there are a lot of predefined functions like orders total. We used like the ibars function, the IMA function. All of these functions are predefined functions, and you can find all of them here. So you can literally just find all the functions that the MQL4 framework has here, and you can read about them here. And this is what I would recommend. If you want to do something specific, just Google it. And in most cases, you will find a function, and then you can read in the reference how this function works. It's really simple once you got this workflow, in your head, and it's manifested there. Okay, so let's have a look at a for loop again. So we said this is like the first thing that happens if the for loop is reached. So we get an integer variable initialized with the value of orders total minus 1. So if we have 1 order, this will be, I will be the value 0, because orders total 1 minus 1. If we have 5 orders or 4 orders, I will be 3. If we have 10 orders, I will be 9. So always orders total minus 1. I will explain in a second why it is like this. Then, after doing this, like the initialization, the second one after the first semicolon, or between the first and the second semicolon, is the main condition of this for loop. So the next thing that this for loop will do is to check if the value inside of this variable I is greater or equal 0. So let me get this again. So here in this case, it's true because I is 0 or greater or equal 0. In this case, it's also true. In this case, it's also true. So it's always true. So whenever we have an open order, this will always be true. So it means after this condition is true, we will directly enter this body of the for loop and we will process it. So whatever is written here will be processed if this condition is true. And after doing this, this part is executed. So I is decreased by 1. So this I minus minus is the same as writing I is equal to I minus 1. So then this happened. So for example, if we have 0 orders, I will then be 0 first, but then it will be subtracted by 1. So then I will be minus 1. If we have 3 or 4 orders, I was 3 first, and then afterwards it's 2 because it's 3 minus 1. So after doing this, we check the main condition again. So the initialization is skipped. It's only processed one time at the beginning of the for loop, but this condition is checked again after every iteration, after every processing of the body. So then we will check if I is greater or equal 0 again. And if I was 0 before, it's now minus 1. So it's no longer greater or equal 0. So at this point, the loop would end and we would process the rest of the source code. But if we have 4 orders, I was 3 before and now I is 2, which is still greater or equal 0. So if we had 4 orders, we will process the body again. And this time I will hold the value 2. Then again, we will subtract I by 1, which means I is then 1. Then afterwards it will be 0. And afterwards it will be minus 1. And at this point we would end the loop. So the more orders we have in the count, the more iterations or executions of this body of the for loop we have. And the value in I is always changing. And this is great because as a first operation in the body of the for loop, we want to say order select, because this will select a position in our account and we will use a index here to specify what specific order we want to select. And this index will be I. Also, we will have to define select by position. And then we can say mode trades, but we don't have to because this is also the default value as you can see here. Here you could choose between mode trades and mode history. So you could select the history also using this order select function. But here we only want to select the open positions. Okay, so what this function does is it will select a order for further processing. So if we find a position at index I, and I will explain this in a second, we select this order. And once we selected a order, we can use the order ... functions. And there are a lot of these. Like for example, we can say selected order at index I, and then we say the ticket is, and then we say order ticket. And this function will give us the ticket of the currently selected order, as you can see in the reference. And this only works, as you can see in the note, that a function has to be selected with the order select function previously. So this is why, first of all, we select the order, and then we can use this print statement and print the order ticket. So let's compile this, and let's run it in the tester again. So what this does is, we will see once we have, like right now, we see nothing in the journal. Nothing is printed, right? But if we see our first signal, it will say open cell order, and also it will say selected order at index 0. The ticket is 1 because the ticket of this order is indeed 1. Because all of the open orders, they are just listed in a list, and this list has a indexing, and it always starts at index 0. So the first order, for example, first order is always index 0. Second order in the count is always index 1. Third order is always index 2. Fourth order is always index 3. And if this order is closed, then this order would be index 1, this would be index 2. So indexing starts always at 0 and then will just increase for every open order. So If we, for example, now speed our test up, and yeah, also you can see like this is always processed once per bar now, this loop, because we put it inside of this passage in our code. But what happens if we have another order open? Like, let's wait for the next buy position. So now we have two orders, right? So it's printing selected order at index 0, the ticket is 1. And selected order at index 1, the ticket is 2, because this buy order is now at index 2 in this account. So let's see what happens if one order is closed. Because now indexing will just change. Now it would say selected order at index 0 is ticket number 2, because now we only have this remaining buy order, and therefore it's at index 0 because it's the only order, and the ticket is still 2, of course. And yeah, it will work like this for as many positions as we want to open. Like right now, this will not become processed at all because we don't have open positions. But if there's another position now, it will be at index 0, of course, and the position ticket is the position ticket of this open position now, 3. So why do we do all of this? Of course, we don't only want to print like this print statement, but instead we want to check if we have to modify the position. So first of all, we want to create some inputs for this. We want to say input double TSL trigger, and it could be something like 0.5%. And then we want TSL percent, which could be 0.2%. Why do we do this? Because now we want to go back to our loop, and here we want to say if order type is equal to OP buy, we want to do something, and else if order type is equal to OP sell, we want to do something. So we know this OP buy and OP sell already because it's just the order property here. And the order type function will give us exactly this. So it will return the order operation for the currently selected order. So this is a way to check in MetaTrader 4 if we are checking or if we have a buy or a sell position selected right now. And if we have a buy position, we want to check if the current bid price is above the order open price, and you can now use all of these functions. Like there are a bunch of these functions, and you can read it in the reference. Like have a look at this. We have the order profit, order swap, order symbol, order take profit, order ticket, order type. All of these functions are now can now be used by us for the currently selected order. So we check if bid is greater than the order open price for the currently selected order plus order open price multiplied with TSL trigger. It's actually TSL trigger percent divided by 100. So let's say TSL trigger percent up here. So we make sure that we don't get a typo. So if the trigger is reached, so our position is at least the TSL trigger percent in profit, then we want to calculate a new stop loss, which will be bid minus TSL percent divided by 100. Oh no, sorry, it's bid minus bid multiplied with TSL percent divided by 100. And then we round this, of course. So round this. Next up is we want to check if this stop loss that we just calculated, if this, this variable holds a value that is greater than order stop loss, which is the old stop loss in this for this position. And again, we can use all of these functions now since we selected the order. And in this case, we want to modify the order. And that's also really easy in MetaTrader 4 programming. You just call order modify function. You have to specify the ticket, which will be the order ticket, the price, the position open price, it's order price open or order open price. This only makes sense to change this for pending orders, but for open positions, you always use order open price or the price that your position was opened at. Then for stop loss, we use the new stop loss value, and for order take profit, we use the old take profit value. Then we could change the expiration, but since this is a market order. We just use order expiration, which is the current expiration value, which is also 0. So we could also say 0, I think. But yeah, I will just go with order expiration. And then we could have an error, but I usually don't do this for order modifications. So if we compile this, there's a warning because we should check the order modify return value. You can easily do this by saying if order modify was successful, because order modify will return a Boolean value anyways. So if you use this if statement, you don't need this semicolon, but instead you close the condition of this if statement and you open the body of this if statement, and then you can just print something like order, wait, did I use the, yeah, you just print something like order number, and then you could say order ticket was modified by trailing stop. You could do something like this, so you always know what's going on in your program. And that's it. That's a trailing stop for buy positions. For sell positions, you can of course also do this. You want to check if the ask price is smaller than order open price minus order open price multiplied with the TSL trigger point percents divided by 100, and then you just calculate the new stop loss based on the ask price, of course, for sell positions. And then you just round this using the normalized double function again. And then you check if this stop loss is smaller than the order stop loss. For sell positions, you also want to check if order stop loss is 0, because if a position does not have a stop loss, it's 0, and then you still want to use the trailing stop usually. So here we can again call the order modify function. This is actually exactly the same as what we did before. Call this function with all the parameters necessary, order expiration, then make sure to add enough closing brackets, and then open the body of this if statement, and then we can have another print statement. So order number, order ticket was modified by TSL, like this. And you could, of course, also say, like here, you could say buy order was modified. Here you could say sell order. You can write whatever you want. Okay, so if we compile this and run the program again, we will see that now if positions run into profit, they will have a trailing stop. Or if I did not mess up the code. So let's see what happens. So sell position, it's running into the profitable area. Not enough. We need at least 0.5% of the price, and then the trailing stop should be processed. Let's see if it's working for a buy position. No, it did not modify the position. So I think I will have to check this again. Maybe I messed up something in the code. Yeah, let me check this quickly again. So at least this buy position should have been modified. So if we have a buy position selected, we want to check if the bid price greater than order open price plus order open price multiplied with TSL trigger percent divided by 100. Bid is equal to bid minus bid multiplied TSL percent divided by 100. Actually, I don't really see my problem here. And whenever you have a situation like this, what I do is I just add a lot of print statement to see where my program is doing what. So I want to check if we even get to this point with this print statement. Then I want to check what this calculation will do for us, like the result here of this calculation. And then I want to check the stop loss that was calculated. So I will just add a bunch of if statements, print statements to see what happens. And also I want to print the order SL. Like this. And if I compile this and run the program again, we will now see a lot of print statements that will give us the information that we need to fix this bug. So let's wait for the buy position so we can actually see our print statements. There is the buy position. So we are getting to the in part of our code. So we get here already. So now we have to check if the trigger is processed correctly. And for this, we will have to wait until the position is in profit for 0.5%, right? So it should be somewhere here. Oh, this was a little bit fast, but it was in profit. Oh, actually, I think I know why this is not working. Let me speed this up again. I think it was not working because this code is only processed once per bar. And there was no situation to process the trading stop because the bar that triggered the trading stop also hit the TP immediately. So let's check this for some more trades. And whoopsala, this was the TP of the buy position. But yeah, you can see now there was a modification, and we should also see it here. Sell order 3 was modified by trailing stop loss. And now we can see that if the price goes down even further, the trailing stop loss is trailed. Okay, so far it only works if there's a new bar, but we can change this. We can just take our whole code of this for loop, cut it here, and then we could place it up here in the onTick function. So if we put it here, paste, of course we always want to move it to the left a little bit so we know it's in the body of this onTick function and on the scope. So now we have it at the beginning of our onTick function. Let me get rid of the print statements also because we know it's working. And now if I run this again and compile it again and run it again, we should now see that also the first position is processed with this trailing stop loss. Because now it's not working on a bar basis, but this is working on a tick basis. So once this buy position is in profit at least 0.5%, which should happen here, you can see now the trailing stop loss is processed with every single tick, and it will trail the stop loss after the price. So this is working just fine. So let me have a look what we still need to do. There's, I think, one last thing that I want to do in this tutorial to show you how you can close trades on a counter signal. So what we want to do here is we want to say if, also since we use the magic number here, we will have to use this because this loop here, it will not only loop through the orders of your expert advisor, it will loop through all the trades in the account. So right now, this EA would manage all the orders in the account, and this is not really what we want. So to fix this, we can say if we are able to select an order and if the order symbol is equal to the chart symbol and if the order magic number is equal to magic, only then we want to process the trailing stop. So this is a good mechanism to make sure that your EA is only processing the order that is opened by itself. And you can just choose a different magic number for every program in your account to make sure that this actually works. So let's have a look at how to close positions if there's a counter signal. First of all, I want to create an input for this so the user has the option to decide if he wants to do this. And this will be a Boolean input. And we can name this is close counter signal. I don't know, something like this. So the user is able to change this. And it can only be true or false. It's a simple switch. So if we compile this and if we go to our loop here again, inside of our loop, like for the buy positions, we want to check if if MA1 fast is smaller than MA1 slow. Oh no, it was MA fast 1 is smaller than MA slow 1. And in this case, we want to close the position, and it's easily done. So write if order close, just a predefined function, super simple, and then we just have to provide a order ticket. And that's pretty much it. Then also we have to provide the order lots, so we know that we want to close all the positions. So say order lots to close all the positions, all the lots of this order, and then we have to provide a price. Usually you close buy positions at the bid price. So say bid and slippage, just a really big number, so we can make sure that the position will be closed at all costs. And then you could write something like buy order number, order ticket was closed because of counter signal. Something like this. So this one-liner here, like the order close function, it will close a position and you specify the position by using the position ticket number. That's pretty much it. And if we compile this, there will be an error. And do you know why? Because both of these variables, they are not available here. They are just not known by the program at this point. And this is because these variables are declared down here in the body of this if statement. So they only live inside of the body of this if statement from this point on. But we can easily fix this. Just take it from here, cut it from here, and then go at the top of your onTick function and paste it here. So we make sure that with every single tick, these variables are declared and they get the correct values. So then we are able to check it here inside of our loop. So if I compile now again, everything works just fine. Also, I want to make sure if this order is closed, we don't really have to check if we have to modify it, right? So after we did this, we can just write continue, because this will directly end the current iteration of the loop, and it will go to this part here where we'll just subtract I minus 1, and then it will check I again for the next position. So let's now do the same thing for sell positions. Here we just want to check if MA fast 1 is greater than MA slow 1. In this case, we say if order close, and it's just completely the same. We close all the lots for this position at the current ask price, and the slippage can be 100,000 again. So we just close the position, and then we want to print sell order number, order ticket was closed by or because of counter signal. And we just continue with the next iteration of the loop. So let's compile this again and let's see if this works, right? So let's make sure. Oh, and we didn't use the switch. So that's also what we can do. Like before we check this, we want to check if is close counter signal is true. So if this is true, and only this variable alone can work as a condition because it's true or false. So we check if this switch is turned to true and this is true, then we want to close the position. But if this is false, we don't want to do this. So we will have to check this here and here. And then compile, run the program again, and let's see what happens with our sell position if the next buy position is opened. Sell position is here. Let's see when the buy position comes into play. Boom! Sell position closed immediately. So, I mean, you can use it if you like. If you don't want to use it, you can just turn the switch off. Like, let me demonstrate this quickly. You can just say false. I don't want to close if there's a counter signal. Let's do the same test again. And yeah, now you can see now we will be able to open two positions at the same time again. So yeah, just like this. And this is our fully functioning moving average expert advisor for the MetaTrader 4. So let me explain this again. Let me, talk you through the code again. Am I fast? Just messed it up. So let's go to the very top of our program. What do we do here? First of all, we have the property strict. Again, I recommend to just use it in your code because it will make you use proper programming. It's always a good idea to use this. Then we have a lot of input variables. Input variables are the kind of variables that can be changed by the user. Like if the program is running somewhere or if it's just activated for the first time, like here, the user will be able to change these input variables and it will make the program function in a specific way. So all of the things that should be modified by the user should be defined as input variables. These variables are then available in the whole program since they are defined on a global scope. Then we have the bars total, which is also a global variable, but this one is not an input variable. We just use this to initialize it in the onInit function, which is called when the program is initialized, and then to check in the onTick function later on, like here, if there's a new bar. But first of all, in the onTick function, we have the calculation of the moving averages. In MetaTrader 4 programming, you can just get the values of indicators by using a specific indicator function. It's IMA for moving averages. Then you just provide a lot of values to tell the PC what specific indicator you want to calculate. And then in the end, you want to say what bar you want to get the value for. And this is why the shift value is there. We store all of these 4 values in double variables because we need this to check if there was a crossover. Then we have this for loop that we just wrote. The for loop will loop through all the orders in your account. And by selecting a order at the position index I every single time, we can make sure that at one point or another, every single order is selected. We also want to check if this is a order that was opened by this specific expert advisor by checking the symbol and the magic number. Then we want to check if it's a buy position or a sell position. If it is a buy position, we want to check if the user said that he wants to close on counter signals, and then we check if there was a counter signal. If true, we just use the order close position to close the position, and we immediately go on with the next order. If we don't have to close the order, we still want to check if we have to process the trading stop. So we check if the current bid price is above the TSL trigger. If yes, we calculate the new stop loss. We check if this new stop loss is higher than the old stop loss. And in this case, we modify the position using the order modify function. We do the same things for sell positions. Then, whenever there's a new bar, we also want to check if we have a buy or a sell signal. So we just check for a crossover using our 4 variables that we have filled with the values for the moving averages. And then we just print buy signal or sell signal and open a position using our own custom functions that we find at the very bottom of our program on a global scope. These functions are just designed to open positions, and they will then return the ticket ID of the ticket that they just opened, or the position that they just opened. And that's it. Fully working program, good to use for testing and also for trading in the MetaTrader 4. That's it. So let me know what you think about this. Were you able to follow along? Did you understand everything, or do you have questions? If you have questions, let me know in the comments. And if you appreciate these tutorials, please leave a like and also subscribe to the channel to really support my work here and to make this content available for more and more people in the internet. So in the end, thanks for watching. Hope you liked it. Have a great time and good trades. Bye-bye.